In section 8.5.2, we will examine the formula that calculates the future value of an annuity in one step. Recall in the previous video, we looked at calculating the value of an annuity at the end of 3 years. It was pretty tedious to do it year by year, but this particular formula will condense that previous problem into a single step. So A is the amount in the account, amount in the annuity, also known as the future value, what it's going to grow to. P, we have been previously calling the principal, or one-time lump sum deposit for either a simple interest or a compound interest investment. But in the context of an annuity, P is our regular payment. And we're going to make the same payment at fixed intervals of time over a specific term. R is the rate of interest, as always. And this is in decimal form. And T is time in years, also known as term of the loan. Looks like I'm missing a variable here. I'm just going to add it. N is number of times interest is compounded per year. There's a lot of different types of annuities out there. In the previous video, I mentioned that there's ordinary annuities versus annuities due. That's simply terminology regarding when you make your deposit. Is it the beginning of the pay period or at the end of the pay period? We are looking at an ordinary annuity where we make that deposit at the end of the period. Also, this is what's known as a simple annuity. What that means is that our pay period is the same as the compounding period. So let's make a note. This is the same as the pay period. So the number of payments that I make per year is going to be assumed to be equal to the number of times interest is compounded per year for our studies in this section. Now, in example 2, we're going to use this formula to find the future value of the annuity that we did back here painstakingly in many steps. So if you'll remember, we were depositing $2,000 at the end of each year for 3 years. The interest rate was 6% per year, and we were looking at annual compounding. So let's put that information into our formula. So this is our guide. This is the formula that we're going to be using. And we want to know the future value. That is, we want to figure out A. So P is our regular payment. Remember, we were making a $2,000 deposit every year, once a year. We talked about maybe that's our Christmas bonus that we are investing in this annuity. The rate of interest was 6%. We were looking at annual compounding, or compounding once per year, and we were looking at a term of 3 years. So N times T is 1 times 3. The formula requires a -1, and then in the bottom we have 0.06 divided by 1. Now, you do not want to make a series of approximations. So plug this into your calculator in one step so that you can evaluate it once. If you evaluate this and round it, and you evaluate this and round, and then you divide and round, you're going to round too many times, and you're going to gain some error, some rounding error. So make sure that you practice plugging these into your calculator in a single step, because a one-time evaluation means I only have to round my answer once. Make sure you get your exponent key in there. And don't forget, and I say don't forget because I forget often, don't forget, use your right arrow key to get down out of your exponent before you subtract 1. I'm going to close parentheses for my numerator, and then I'm going to enter the fraction bar as divided by. I'm going to open parentheses again for the denominator, 0.06 divided by 1, and close parentheses. So the future value of this annuity, according to this formula, is 6367.20. 63 $67.20. So in that single step, using this single formula, notice we have obtained the same answer that we got by calculating it year by year. So it's a very efficient and useful formula. Annuities are a very common way to save for retirement. You can contribute to the account, for example, on a monthly basis. So you are contributing to the growth of the account, and at the same time, the account is gaining compound interest. So this is a very common, very useful way to save money over a long period of time. These are very easy to set up, and sometimes employers will offer you the opportunity for an automatic draft. They'll take the payment right out of your account, deposit it into your annuity before you even know that it is missing. Let me remind you also that this would be an example of an adjustment. Whenever we studied income tax, we took our gross income and we subtracted our adjustments. Any sort of payment that we might make into an annuity over the year would be an adjustment to our gross income. It reduces our taxable income, reduces the amount of tax that we have to pay. So let's try one of these examples. You decide to set up a retirement annuity at age 25. You would be very wise in doing so. Even if you're not 25, let's say that you're an older student and you've come back to school to get another degree, a different degree, or maybe even your first degree, you can set up an annuity at any time, and it is still a very wise way to save money. Okay, so back to our example. You're going to set up your retirement annuity at age 25, and you decide to deposit $100 per month every month for 40 years. So the term of the annuity is 40 years. Your payment is $100 per month, and you're doing that 12 times a year. And we're going to look at a rate of interest of 7%. Okay, here's an exciting question. What is the future value of this annuity at retirement? So I'm going to write our formula down here so we can see exactly what's being plugged in where. Double parentheses there. Okay, so our payment P is $100 per month. Double open parentheses here. 1 plus the rate, our rate of interest is 7%. We're looking at 12 payments per year. We're also assuming that interest is compounded 12 times per year. We're going to do this for a long period of time. So if you did this from age 25 for 40 years, this would bring you to retirement age 65, divided by 0.07, R divided by N12. Okay, let's get this typed into our calculator. So we're going to start with our $100 deposit, open parentheses twice, 1 plus 0.07 divided by 12, close parentheses, exponent, 12 times 40, right arrow key to get down out of the exponent, then subtract 1, close parentheses, fraction bar gets entered as divided by, open parentheses again, all parentheses are necessary and important, 0.07 divided by 12, close parentheses. Okay, drum roll, you ready? Your retirement value, future value would then be $262,481.34. This, by the way, is a very modest deposit, $100 a month every month for 40 years in an annuity that earns 7% compound interest. At the time of retirement, you will have over $250,000. Now, here's the interesting question. How much did you contribute to the account? Well, let's see. You deposited $100 per month. That's 12 times per year, and you did this for 40 years, faithfully for 40 years. Or maybe it was just an automatic draft from your account. $100 a month, 12 times a year for 40 years. You deposited $48,000 into the account. Here is the fascinating question. How much interest did you earn? Well, we're going to find the interest, we're going to take the future value minus the sum of our payments, or our contribution. The future value was $262,481.34. Our contribution was only $48,000. So let's see how much interest we earned. The interest we earned is $214,481.34. $214,481.34 in pure interest alone. Can you see why Einstein called compound interest a miracle? You, again, have a modest deposit, $100 per month every month for 40 years of your working life. You only deposited $48,000, but it grew to over $250,000, $262,481.34. This is a very, very wise thing to do, and it's a great way to save for retirement. So when you get your degree and you get out there in your career field, even if your employer does not offer you this option, if they don't have benefits set up for you, you can very easily go to a bank or a financial institution and set up a simple ordinary annuity, and it's a powerful way to provide for yourself and your family in the future. So really consider this. Also, I would invite you to experiment with this formula. Say, consider your own monthly budget, right? What can you afford per month? How much time between your age now and retirement? Plug it into the annuity formula, research rates, and figure out what's your potential future value in that retirement account. It's a really interesting experiment.